The second method to analyze any circuit is to use what we call it mesh analysis. We have nodal analysis and we have mesh analysis. Mesh analysis depends on Kirchhoff-Volch law, and nodal analysis depends on Kirchhoff current law. As you have seen before, at each node we apply Kirchhoff current law. In mesh analysis, we have meshes, and in each mesh we apply Kirchhoff voltage law. So in mesh analysis here we have, for example, if you look at this circuit here, the step is to count the meshes. If you remember the definition of mesh is a loop, so it does not have internal loop. So for example, here we have two meshes, this mesh and this mesh. And then for each mesh, we create what we call it a mesh current, which is not real current. The mesh current, which is not a real current. And I will define the mesh current later on. And see what's the difference between the mesh current and the real current or the branch current. So the first step, again, is to define number of meshes. Okay, in this example, it is 2, 1, 2. Second, for each mesh, you assign a current like this, like I1 and I2. And all of them should be in the same direction to make it easy. Okay, so for example, all of them are clockwise direction. So here's I1, I2. All of them are in the same clockwise or counterclockwise, same direction. Then you apply Kirchhoff voltage law in each mesh, which will be very easy. The Kirchhoff voltage law will take this shape in this case. How it look like? You see, it look like this. In, for example, I'm talking about mesh number n. N is 1, 2, 3, whatever. So In could be I1, I2, and so on. You multiply by what? By R total in this mesh. The total resistance in this mesh. Total here does not mean that you have find the total like in chapter 2. No. You add the resistors in the mesh. So for example, if you are talking about mesh number 1, the current In is I1. This is the main current in this mesh, I1. Time what? Times this resistor or resistance here, plus this resistance, plus this resistance. You have 3 resistors. 1, 2, 3. So you add them. So it will be I1 times 1, 2, 3. Minus summation of what? Of the intersection. You look at the intersection with this mesh. So for example, mesh number 2 intersect with mesh number 1 in this resistor. So it will be minus I2 times this resistance. I2 times this resistance. If you have another mesh like this here, and you have I3, so it will be minus I3 times this resistance here. The intersection, the resistance that has the intersection between the two meshes, and so on. And in the right hand side, you add the voltages in this mesh. So here, for example, how many volts you have here in this mesh? Only one, this one here. That's it. So this is how you do it. And you will understand it more when we have examples. But let me tell you here first what is the difference between mesh current and branch current. Mesh current is imaginary current. You can consider it, for example, that the current is moving inside the mesh. Like, for example, if you look at this one here, I1 and I2. Look at I1. I1 is the red one here. You see? As if it is running inside the mesh from the inner half, like this. You see, this is I1. I2 is the blue one. I2 is the blue one. Which means that, for example, mesh or branch like this one here, the branch in the middle, it has two currents, two mesh currents. One from the left, one from the right. Okay? And if you want to find the relation between the real current, the branch current, like IY, for example, IY, and the mesh currents. So of course it has relation with I1 and I2 because this branch has both currents. So IY equal what? Equal, of course, I1 because it is in the same direction of IY minus I2, which is opposite to IY. For example, if I want to calculate IX, is a branch current. Okay, Ix has relation with what? With I1 here, the red current. Doesn't have any other mesh current. Okay, so it will be Ix equal what? Equal I1, because they are in the same direction. What about IW? IW is opposite to it, opposite to I1, so it is minus I1. IM is also opposite to I1, so it will be negative I1. I0, this I0 is opposite to I2, then it is negative I2. What about IZ? IZ is the same direction of I2, then it will be equal to I2. IN is opposite to the mesh current 2, I2, then it will be negative I2. So look at this, for example, here, I zoomed it. So it's very clear that Ix, for example, is what? This Ix, same this direction from left to right, it is equal to I1, which is the red one. For example, IY, you see, IY is moving down here. Then it is in the same direction of I1, red one, and opposite to the blue. Then it will be the red minus the blue, I1 minus I2. IZ is opposite, is the same direction of the blue, which is I2. So it is equal to I2. IM is opposite to the red, that is negative I1. IN is opposite to the blue, that is negative I2. I0 is in the same opposite to I2, then it is negative I2, and so on. So now let us solve this problem using mesh analysis. How many meshes we have here? We have three. We have three meshes. So we have this I1, I2, I3. Notice that they are all in the same direction. They are all clockwise. Okay, so now let us write equation for mesh number 1. What is the main current? Apply this equation here. The main current is what in mesh number 1? I1. The main current is I1. So it will be I1 times 10 plus 12. 10 plus 12. So I1, this is the main current. Time what? Time 10 plus 12 minus the intersection. This mesh intersect with the other mesh in what? Intersect with mesh number 2 in I2 in 10 ohm. Intersects this mesh here is highlighted, or so this mesh, you see this mesh, this is mesh number 1. It's very clear that it is intersecting with mesh number 2 in what? In 10 ohm. So it will be minus I2 times 10, minus I2 times 10. And it intersects with mesh number 3 in the 12 ohm. So it will be minus I3 times 12, minus I3 times 12. Equal what? Equal the source. How many sources we have here? We have this 24 volt. So equal 24 volt. Could be positive, could be negative. Okay. So depending on what? Depending on the direction. So now let us look at the direction of the voltage source. The direction of the voltage source is from negative to positive. This is the direction of the voltage, from negative to positive. Okay, so now is it in the same direction of the clockwise of the current or not? So let us see. Here is the current. The current is moving in this direction, right? So in this branch, the current will be in the same direction of the voltage. Then 24 is positive. 24 is positive in this case. But if it is opposite to it, then it will be negative. Let's go to the second mesh. Second mesh is this one here. This is the second mesh. So the main current is I2. So it will be I2. I2 time what? Time 10 plus 4 plus 24. 10 plus 4 plus 24. These are all the resistors here in this mesh. 10, 4, 24. Then minus the intersection. Okay, this mesh intersect with I1 in what? In 10. Intersect with I1 in 10. Here it is. This 10 ohm. And intersect with I3 in what? In 4. So it will be minus I1 time 10 minus I3 time 4. Okay, that's it. equal what? Equal the sources. Do we have any source in this mesh? No. Then it is 0. Then it is 0. Let us look at mesh number 3. What is the main current? The main current is I3. Okay, this is the main current here. Is I3. So it will be I3 time what? I3 time 12 plus 4. 12 plus 4. Minus the intersections. The intersection. This mesh intersect with I1 in what? In 12. And intersect with I2 in 4. So it will be minus I1 times 12 minus I2 times 4. Okay, equal what? Equal the source. The source is 4I0. 4I0. 4I0 is positive or negative. This is depending on the direction. So now let us look at 4I0. Here's 4I0. Okay, is it positive or negative? It is negative. You see here the direction of the current in this branch is opposite to the voltage source. Then it is negative 4I0. Okay, then now we have the 3 equations. We finish equation 1, equation 2, and equation 3. Next, we need to find I0. I0, because I0 is one of the unknowns here. We don't need I0. We need only 3 equations, I1, I2, and I3. So where is I0? I0 is this current here. 0 is this current here. So I have to find this I0 in terms of what? In terms of the mesh currents. So let us see. Here's I0. I0 moving in this direction. Here it is. Let's see. Here's I0. I0 is this one here. This is I0. Okay. Where is I1? Of course, it has a relation with I1 and I2. I1 is in this direction. This is I1. So it is in the same direction of I0. What about I2? I2 is in this direction here. It is moving like this. So in this branch, it is opposite to I0. So I0 equal what? I0 equal I1 minus I2. And this is what we have here. Okay. So this is the solution of the problem. Now we have 4 equations and 3 equations, 3 unknowns. We can solve them. Find I1, find I2, find I3. Once you have these currents, you can find any voltage and any current in the circuit. Let's see what's next. For example, we have this problem and I want to solve it using nodal analysis and mesh analysis. If we start with mesh analysis, here we have two meshes, I1 and I2. It's very clear. Okay, so now let us see. For mesh number 1, the main current is I1. Time what? Time 4 ohm plus 6 ohm. 4 plus 6. Minus this mesh number 1 intersects with mesh number 2 in 6 ohm. So it will be minus I2 times 6. I2 times 6. Equals the sources. Here we have 2 sources in this mesh. We have 10 volt, which is this direction, which is very clear that it's the same direction of the mesh current. And we have also 2 Ix. And both of them are in the same direction of the mesh current. If you don't see it, let us see. I1 is clockwise. So let us draw it like this. Okay, here it's moving like this clockwise. You see, it is the same direction of the 10 volt. And then continue like this. It is in the same direction of the 2Ix. So this is how it look like. I1 clockwise direction. Then it is in the same direction of the 10 and 2Ix. Then this will be the first equation. The second one, the main current is I1. The main current is I2, sorry. The main current is I2. Okay, time what? Time 6 ohm and 2 ohm. 2 and 6. So it will be time 2 plus 6. 2 plus 6. Then minus the intersection. Of course, this mesh number 2 intersects with mesh number 1 in 6 ohm. That will be minus I1 times 6. Minus I1 times 6. Equals the sources. We have only one source here, which is for 12 volt. 12 volt is opposite to I2 because it is counterclockwise. If you can see this, you can look at this is a second mesh. There it is. The second mesh look like this. Then the current is moving like this, the clockwise direction. There it is, and so on. It's a clockwise direction, and the voltage 12 volt is opposite to it. Okay, that's why it is negative 12, not positive 12. We have to find also Ix. We need to find Ix in terms of what? In terms of I1 and I2. Ix is the current in the middle here. And as I explained before, for this example, it is very similar to this one. But let's do it again. So here's Ix. Ix is moving in this direction here. This is Ix. Okay. I1 is in this direction, is moving like this. So in this branch, it is in the same direction of Ix. And I2 is moving clockwise like this. Then in this branch, it is moving opposite to Ix. So Ix equal what? Equal I1 minus I2, which we have here. Let's look at nodal analysis. Just remind yourself with nodal analysis. So here we have only one node. We have only one node. So it makes sense that in this case, calculation-wise, nodal analysis should be easier because you have only one node. This means that you have only one equation. But in mesh analysis, you have two meshes, then you have two equations. You have to solve two equations into one node. But also, again, this is up to you. It's not a big deal. So now let us look at this one using mesh analysis, but let us erase this. Erase over everything. Okay, so let's do it. Okay, so we have here three branches. We have three branches. Okay, we have three currents here. 1, 2, 3. And then we need to add or write equation for each current. This one is very easy. Just V1 divided by 6. So let's make. So here, this is this current is V1 divided by 6. This is supposed to be ground, of course. We have to add this as a ground. Okay, what about the second current? This current here, it is V1 minus the voltage here. So voltage here is 12 volt. The voltage is 12 volt because this is 0. This one is 0. Then this one is 12 volt. So it will be here. It will be V1 minus 12 over 2. Okay. Second one, the last one here. This is the last one is a little bit tricky here. You need to find the voltage here. The current is moving from V1 to the ground. Okay, so you need to find the voltage. Where it is. You have this 4 ohm. So you need to find the voltage here and the voltage here. So it is this voltage minus this voltage divided by 4. This voltage is 10. You don't have any issue here. This is just 10 volt. Right? Because this is 0, then this is 10. Okay, so we know this is 10. What about the other voltage? The other voltage we have to look at or before the source. Here it is V1. And this is positive. This is negative. Okay, so what about this one here? So this one is what? Is V1 minus 2Ix. This is 2Ix. It is 2Ix. Okay, then this one will be V1 minus 2Ix because it is in the negative side. So if you have a source, you always do that. This is V1. This will be V1 plus or minus 2Ix, depending on the sign here. The sign is negative, then it is negative. Then in this case, the current, this current here, the third current equal what? Equal V1 minus 2x, V1 minus 2ix. Okay, you can add a bracket here, or you can leave it because it is in the front, minus 10 volt divided by what? Divided by 4 ohm. 4 ohm. Okay, so now you have the three currents, you add them, the total is 0. Then this is nodal analysis for this problem. Okay, we need to find Ix also, Ix. But Ix here is very easy. Ix is just V1 divided by 6. Ix is V1 divided by 6. Here, that's why we have it here. Okay, so this is the solution of this problem using mesh analysis and nodal analysis. Nodal analysis is easier calculation-wise, but because you have only one node, but it is a little bit tricky. You have to be careful. In mesh analysis, it is very straightforward.